Okay, just to recap what we've done the last couple sections, we did one about expressions. And so if you're dealing with an expression, you need to combine those into one fraction, right? So you need the same denominator. So we talked about that, like this one is lacking an x. This one is lacking a 3 here. And so once you do that, you get 9 over 3x plus 2x squared over 3x. And so the final answer there would be 2x squared plus 9 over 3x, because I don't think it simplifies any more than that. We learned how to deal with complex fractions, right? So you have a fraction within a fraction. You can usually just take that and say, well, that's equal to the first fraction times the reciprocal of the fraction you're dividing by, which would be x over 4. And if you do that, you see the x's nicely cancel. And you get 3 over 4 times x plus 2. So today we're talking about equations. And my favorite method is to multiply by LCD. So this is a little different. Now notice, like in the past, we always had to do like this kind of thing, like x divided by x, multiplied by 3 over 3, right? We're always like trying to just not change the value of the expression, so we have to multiply in the numerator and the denominator. Here's what's different. I'm really only going to, once I find my LCD, I'm only going to multiply the numerator by the LCD, not top and bottom, not numerator and denominator. So because of the equal signs, we're allowed to do that. As long as you multiply both sides by the same amount, you're good, right? So first thing you might do is just kind of simplify this a little bit. So we have x over x plus 3 plus x over x minus 3. And you definitely want to simplify that. And you get 2 over x plus 3 times x minus 3. Okay, so we're going to multiply everything, and I do mean everything, by the LCD. In this case, the LCD, like, what do you have there? You have an x plus 3, and you have an x minus 3, right? So the common denominator is you're definitely going to need both an x plus 3 and x minus 3. So I'm going to multiply every single term by x plus 3 times x minus 3 only in the denominator, only in the numerator, right? I'm not multiplying the denominators. In fact, my goal in doing this is to get rid of the denominator. I don't really love fractions. I don't want them to hang around too often here. So we're going to solve this. We're going to get rid of the fractions. Now, this very first time, I'm going to show you the work, but after, you'll probably skip this in between step the next time you do this. So if I multiply that first fraction, which was x over x plus 3, I'm going to multiply by x plus 3 and x minus 3 in the numerator only. Plus the second fraction was x over x minus 3. And again, I multiply the numerator by x plus 3 times x minus 3. And then 2 over x plus 3, x minus 3. I'm going to multiply that by x plus 3, x minus 3. Okay, so again, a lot of people just kind of skip the step after they kind of get used to what's happening here. So obviously the x plus 3's go away, the x minus 3's and this one goes away, and the x plus 3 and the x minus 3 goes away there, and you're left with a pretty basic equation at this point. So now we have x times x minus 3 plus x times x plus 3 equals 2. Right, so just kind of distribute and simplify x squared minus 3x plus x squared plus 3x. So that's 2x squared on the left. The 3x kind of disappears there, divide by 2. Get x squared equals 1. Take the square root of both sides, don't forget. Plus or minus. So you get x equals plus or minus 1. So we get two answers there for x, right? So we get x is equal to 1 or negative 1. And just kind of check the denominators, make sure like everything looks good there. If denominator is 1, I mean, it has a a 1 in there for x, I think you're okay here. We'll get to some problems where that's not the case here. So we have 2 answers, and we solved it, right? We're not solving really for the y value. There's no y value here, so we're just solving for x, and we got both answers. Is this the same problem? I believe it is, right? So the first method was multiply by the LCD. I'm just going to show you another method of doing this if you wanted to. You might like this better. I don't know. I think the LCD method is pretty fast, especially when we kind of skip that step there. But let's do the old-fashioned method here. So this is another way of doing it. So x over x minus 3 plus x over x plus 3 equals 2 over x plus 3, x minus 3. So this one is missing an x minus 3. So x minus 3, and multiply top and bottom. This one's missing an x plus 3. So multiply x plus 3 top and bottom. So if you do this, like now we have the same denominators. I guess we can add this together, right? Do it this way. So you get x squared plus 3x plus x squared minus 3x over x minus 3, x plus 3 equals 2 over x plus 3, x minus 3. Since they're both, at some point, don't we need to multiply by the LCD, right? I mean, the top left, what there will be x, 2x squared. Top right will be 2. But we still have this pesky little denominator, x minus 3, x plus 3, but they're the same on both, right? X plus 3, x minus 3. So don't we at some point have to multiply everything by the LCD, which is x minus 3, x plus 3? When you do that, right, the denominator goes away, you get 2x squared equals 2, and you solve from there like we had before. But because you have to cancel out that denominator. So we're just kind of like circumventing the system and say, well, let's just do that earlier on. It's so much easier just to multiply with LCD at the beginning because all the denominators kind of go away. In fact, if you'd done this from the beginning, it's just faster, right? So that's one thing to think about there. Again, I want you to factor anything you can. So right away I see and put parentheses around everything that's a binomial. Definitely put parentheses. Heck, it doesn't even matter. You can even put parentheses on 2x. That's great. Okay, so let's simplify this first one, and then that will help us figure out what the lowest common denominator is. So we get this is x plus 2 times x plus 1 plus 2x over x plus 2 equals x minus 1 over x plus 1. So if you look at this problem, we go, okay, I got an x plus 2, we got an x plus 1. So I hope it's obvious that the GCF is both x plus 2 and x plus 1. So I'm going to multiply only the top, not top and bottom, and both sides by x plus 2 times x plus 1. So this time I'm going to skip that step. In other words, I told you there's kind of a shortcut most students use when they multiply this out. They don't show every little step here. So let's just kind of shortcut it just a little bit. And here's what I mean by that. So do you see what's going to cancel when you distribute to the first term here? So both the x plus 2 and the x plus 1 are going to cancel. So you're left with just, well, x minus 1 plus go to the next term. Don't you think the x plus 2 is going to cancel here? Right? So really all you have is 2x times what's left over, which is the x plus 1. And here, don't you think the x plus 1 is going to cancel? When you distribute all the way over to here, the x plus 1s will cancel. So you still have the x minus 1 up there, and you multiply by x plus 2, which is the other one. And now we're going to solve this. So in one step, you just get rid of the denominator so fast, right? So x minus 1 equals 2x squared plus 2x. equals x squared. Inside is minus x plus 2x is plus x minus 2. Let's get everything over to, this is a plus here, it's a plus. Let's get everything over to the left-hand side. So I'm going to subtract the x squared. Subtract x and add 2. Okay, that goes away. Okay, so let's simplify this a little. So we get, let's see, 1 plus x squared plus 2x equals 0. I don't like the order of that, so I'm going to say x squared plus 2x plus 1 equals 0. I'm hoping that factors. I think it does. So it's x plus 1 times x plus 1. The solution is x equals -1 for both of them, so that's a plus there. That's a plus. So x equals -1, and be careful. What I mean by careful, you might be tempted just to circle this and move on, but if you look at the denominator, if you plugged in a -1, that'd be -1 plus 1. That denominator would be 0, which means this is not a real solution. It's called an extraneous solution. So the actual answer is no solution. There is no value for x that makes that true. Solving in the calculator. So this is not too bad. You got to set the equation equal to 0. So you got to move that 1 over to the other side. So I'll have 2 over x plus 2. Again, I usually write things in parentheses when it's a binomial in a fraction. So x minus 2 minus 1 equals 0. So I just subtracted 1 from both sides. So we're going to graph that left-hand side. So we've done this before, I think. So you're going to graph. Okay, let's do control divide 2 over x plus 2. This graph may look kind of strange. Plus x over x minus 2 minus 1. I don't graph the equals here. Wow, it's a really strange looking graph, right? So we just want to trace that and find the intercept. So menu 5, 1. And right away, I see an answer is x equals 0. Solution there. If you scroll to the right, wow. Right, like, I mean, it's kind of like an asymptote of 0. Can you tell that? So it's not actually ever gonna, it's just approaching it. You go -8 here. You can see it's getting closer to 0 for the y value, but it's never actually getting there. So it looks like the only places across the axis is at 0. So that's your only solution for this problem. Double check it in the denominator. Even if x is 0, the denominator will not be 0. So that looks to be a legit conclusion. Solution, also not a bad idea to plug it in, like 2 over 2 plus 0 is 2 over 2 is 1, that equals 1. Solve by graphing your calculator. Okay, so again, we want to subtract the 5, get on the other side, so x plus 2 over 1 minus 2x minus 5 equals 0. Menu 5, 1. I get an answer of x equals 0.273. So that looks to be the only place that crosses the x-axis. So we've got an answer. Solve by hand. So wow, this looks like a really interesting problem. So let's try to solve this. It says solve by hand, not the calculator. So let's try it. The first thing you want to do, obviously, is factor. Maybe you see some factoring there. There's not a whole lot, but there's a little bit of factoring. So 2n plus n plus 2 over n plus 1. That's equals -2 over n times n plus 1. So let's look what we have for GCF. So we have an n plus 1, we have an n. I think there's only two things we have, right? So we're going to multiply everything by both an n and n plus 1. So n times n plus 1. It's going to distribute to every term. So when you do that, this first term, the n's are going to cancel. So you get 2 times, well, n plus 1 is still have to be multiplied, plus 2 to the next term. N plus 1 is going to cancel, so that n is going to have to multiply by the n plus 2 here. And multiply by the third term on the other side of the equation, that would be, oh wait, n and n plus 1 cancel, so you're just left with negative 2. Oh, that's kind of nice, right? So you get 2n plus 2 plus n squared plus 2n equals negative 2. You get n squared plus 4n. I'm going to add 2 to both sides, plus 4 equals 0. So this actually factors to be 2 and 2 must be plus and plus. So n equals negative 2. Sorry, n equals a negative 2. So I think that's my answer, but if we plug it in, let's just double check here. Yeah, n plus 2 works there. N plus 2 plus 1 is, negative 2 plus 1 works. Negative 2 times negative 2 plus 1, that works. So it works. We've got our solution. That's it. Let's go to PSAT. No, there wasn't one. We're good.